Hi, 1.1b. Today we're going to talk about radian measurement. Radians is similar to degrees, but it's completely something different than you haven't heard of before. So when we talk about radian measurement, again, our angle is still theta, like we talked about yesterday. So again, this is the Greek term for theta, or in other words, this is what we call your central angle. Now, what do you know about a circle? We know that the radius is the same all the way around the circle. So if we were talking about the lengths of the radius, both of these lengths that create theta are exactly the same. Okay? If we say that this is the circumference of the circle, circumference, if you remember from geometry, is 2 pi r. Therefore, the degrees all the way around is 360 degrees, which is the same as 2 pi r. So this is degrees, and this is what we call radians. Okay? If we let r equal the radius, and we let s equal the arc length. The arc length is this part right here, S. Then we know that the angle, theta, equals S over R. The arc length divided by the radius. Okay? If this equals each other all the way around, then we know that theta equals 1, because S divided by R is the same as each other. Now, all I'm trying to do is prove to you what one full rotation equals. One full rotation all the way around the circle, you know from yesterday, is 360 degrees. But today, all the way around the circle, we're going to talk radians, which is the same as 2 pi. Why am I not saying 2 pi r? Because remember up here, we let the radius equal 1. That means half of a rotation. Well, half of 360 is 180 degrees, and half of 2 pi is 1 pi. A fourth of a rotation, you know as a 90-degree angle from yesterday, but today we're going to look at it in terms of radians, which is a half of pi. Yesterday we talked about the degrees all the way around. Today I want you to be thinking in radians. So this would be 0 pi. We talked about all the way around is the same as 2 pi. So what's halfway between 0 pi and 2 pi? 1 pi. What's halfway between pi and 0? Half a pi. So do you see how these are getting, instead of 90 degrees plus 90 degrees plus 90 degrees plus 90 degrees, it's a half a pi plus a half a pi plus a half a pi, and instead of saying 1 1/2 pi, we're going to leave it as an improper fraction, 3/2 pi, plus another half a pi brings us to 2 pi. Now, radians can also be measured in the actual numerical value. So 0 times pi is still 0. But 3.14 divided by 2 is approximately 1.57. Pi is approximately 3.14. 3/2 times pi is approximately 4.71. And 2 times pi is approximately 6.28. So radians can be in terms of pi or in terms of the decimal. So just like yesterday, we talked about what quadrants do the angles lie in. Today, we're thinking about it in terms of radians. So pi over 5, that's the same as saying 1/5 times pi. Well, where's a fifth of a pi lie? If you want to quickly remember that a half a pi is up here, 0 pi is down here, so a fifth of a pi is approximately right here in quadrant 1. 7/5 of a pi is the same as 1 2/5. So that means I have to go a whole pi and then 2/5 more of a pi. Now, where's 2/5 more of a pi? Is that more than half? Nope. Half would be 2.5 over 5. So it's not quite another half a pi. So what quadrant does this angle lie in? Quadrant 3. Now, there's no pi symbol here. However, is there a degree symbol? There's not. So when we see a number with no degree symbol, we're still talking radians. And those are the radians that I talked about up here, the decimal equivalents. So we're looking for negative 2.5. Well, if I went positive 2.5, it would be somewhere in between 1.57 and 3.14. But I'm going negative that same distance, so negative 2.5 would be the same as me going this direction, not quite to 3.14. So this also is in quadrant 3. I have one more that I would like you to try, this time on your own. So pause the recording for just a second and tell me what quadrant negative 7 lies in. Now remember, negative 7, I do not see a degree symbol, so it must be in radians. And we learned that negative yesterday goes down. So I'm going to go down, and all the way around is the same as 360 degrees, or 2 pi. But we learned today that 2 pi is the same as 6.28. So I'm going to go a little bit further, and we are in quadrant. Okay, just like yesterday, we talked about coterminal angles. Remember, that's when we added 360 degrees or subtracted from 360. Well, today, instead of 360 degrees, we're going around 2 pi. So what is a coterminal angle for 13 pi over 6? Well, the first thing I would suggest doing is sketching it. 6 goes into 13 2 times with a remainder of 1/6. So where is this? Well, we're going all the way around 2 pi and another 1/6 of a pi. So there is my angle. Now I need a positive coterminal angle and a negative coterminal angle. Well, I can see right here, remember the definition is it starts and stops at the same spot. So if I start here and stop here, we're now in the same spot. Well, what angle is that? Well, remember, we went all the way around at one time. So 2 and 1/6 pi, if I take away 2 pi, now I'm left with 1/6 of a pi. So that is the positive coterminal angle. Again, the definition of a coterminal angle is it has to start and stop at the same spot. Well, what happens when I go negatively? Well, it's almost 2 pi around, except for I have to take out this little chunk right here. So what is 2 pi minus 1/6 of a pi? Well, this is where either you need to get your calculators out, or remember that you have to have common denominators before you can subtract fractions. If my denominator is 1/6, then 2 is the same as 12/6. 12/6 minus 1/6 is 11 pi over 6. Now, before you circle that as your answer, remember, what direction did we go? We went down. So down means this is a negative 11/6. Try negative 2 pi over 15. What are the positive and the negative coterminal angles? Pause your video and try it. I do find sketching this helps me have a visual. Again, remember when we start and stop at the same place, that is the definition of a coterminal angle. So this one, I went all the way around and another 2 pi over 15. So what is 2 pi plus 2/15 pi? Again, go ahead and use your calculator, or my common denominator of a 15 means 30/15, and that means 32 pi over 15. Now remember, what direction did we go? We went down first, so this is a negative 32/15 pi. So what is the positive coterminal angle? Well, I have to go that direction opposite or up. So now I'm going to start here and go up and end there. Well, did I make a full circle? I didn't. We know a full circle is 2 pi, but I have to take away this little piece right here, which is 2/15 pi. So again, using your calculator or understanding fractions, 2 pi is the same as 30/15, because 30 divided by 15 is 2, minus 2/15. 30 minus 2 is 28/15. I cannot reduce that anymore. I went in a positive direction, so it is a positive coterminal angle. I'm going to try one more with you to make sure you're feeling confident. So you again try this last one on your own. Pi over 12. What is the positive and negative coterminal angle? Again, I drew a sketch where pi over 12 would be. I started in the same spot, went all the way around and ended in the same spot, so I went 2 pi plus 1/12 pi more. I made 2 pi into 12ths, added my like terms, and got 25/12 pi. The negative coterminal angle has to start and end in the same spot. However, it is not going all the way around. I know it's 2 pi, take away this little piece right here, which is 1/12 of pi. 2 pi is 24/12 minus 1/12, which is 23/12 pi. However, don't forget, what direction are you going? Down. So when we go down, that is a negative angle. I know that it's different. I know that it's scary. Radians are different because of pi. However, you've got to push yourself to try these, okay? Because a lot of trig is in terms of pi. So we're going to just go slowly and give it your best, and tomorrow I'll be sure to answer as many questions that you might have.